In this problem, we've got a function of this form here where a is 1. The coefficient of the sine function is a 1, so the amplitude is going to be 1. So it's going to go as high as 1 as low as negative 1. And c is 0. There's nothing to be added on the outside here, so it's not going to be shifted up or down. But there are still two changes. There's a period change because my b is not 1. It's pi over 2 in fact. And now in the parentheses here we have this x minus d, where d moves to the right if it's positive and to the left if it's negative. So since my d is 3, I'm going to have to move the sine function to the right 3. But before doing that, let's figure out the new period. The b value in my problem is pi over 2. Here's the formula for the period for sine and cosine. Remind yourself this is not the formula for tangent and cotangent, but for sine and cosine, it's 2 pi over b. And in my example, the number here is b is pi over 2. So if I substitute b with pi over 2, I could think of this fraction as 2 pi over 1 being divided by pi over 2. In math, when you have a complex fraction, you can change the division multiplication, reciprocate the second fraction. So here I'm multiplying by the reciprocal of this fraction. Instead of pi over 2, I made it 2 over pi. Pi divided by pi is 1, so these simplify out, and you get 2 times 2 is 4. So normally we would start at 0, 0, and get a sine function here with an amplitude of 1, and make sure that it would take 4 units for it to have one full period. So it looks something like this. It starts at the origin, hits the x-axis on its way down, hits the x-axis second time on its way up, and it would take 4 units to do so. So if it wasn't for this minus 3 here, this would be the correct graph of y equals sine of the quantity pi over 2x. Unfortunately, we have that minus 3, which shifts to the right 3. Now if this was a plus, it would shift to the left 3. So at any rate, I don't think I can just grab this and move it to the right 3 units. That would be handy. Let me see if that works. If I grab this and move it over, it just changes the period. So I'm basically going to have to start over. But instead of starting at the origin 0, 0, I could start at, since we're moving to the right 3, I could start at 3, 0 and just make sure my period's 4. So let me clear this. Click the second icon. Instead of starting at 0, 0 and moving over to a period of 4, I'm going to start at 3, 0 because it got shifted to the right 3. Let me move up just a little bit so that I can see the function. And I'm going to move over so that the second x-intercept now is 4 units from where I started. I'm starting at 3, so 4 units to the right would be at 7. So I need to make sure that the period is from 3 to 7. So the way I've graphed this is, if you think of it starting its period at 3, it goes up, goes down, and it hits the x-axis the second time to the right of my starting point here at 7. And between 3 and 7 is 4 units. So that came from the fact that our period was 4. So I have graphed that every 4 units the graph does one full cycle. So here we are at 3, does one cycle, ends at 7. So my period is correct. And my amplitude is 1. Looks like it needs to go a little lower here. So let me see if I can grab this and move the graph a little bit down. There we go. So now it goes as high as 1, as low as negative 1. The period is 4, but it got shifted to the right 3. Notice the graph is not going through the origin like the sine function usually does. So instead of starting at 0, 0, my technique was to start at 3, 0 and simply graph it. So good luck, and then on to the next problem.